Hi, I'm Beth from My Tutoring Bee, and in today's video we are going over parallel lines and how to tell if lines are parallel based on their slopes. I have a few examples. Let's go ahead and get started. All right, we're going to start off with these graphs. The first thing that I want to talk about is that when we're looking at the slopes of lines, two lines that are parallel to each other will have the same exact slope, but they should have different y-intercepts. Let's jump into these two problems and see what that looks like. So visually looking at these two lines, they look parallel to each other. They're not touching each other, and they look like they are about the same distance apart on both sides of this graph here. But let's go ahead and prove that they are parallel mathematically by finding their slopes. Now I do have another video about how to find slopes from a graphed line, so I will link that in the description below. Let's take a look at these 2 points right here. I'm going to go ahead and connect these 2 points and find the rise over run in order to determine its slope. So we have a rise of 1, a run of 2, so our slope for this line is 1 over 2. All right, now let's take a look at the slope from our next line down here. Again, we're going to just connect 2 points with that right angle. Our rise is 1, our run is 2. So our slope here is 1 over 2. And so since these two slopes match, then these two lines are parallel to each other. All right, let's take a look at our next example. Now, hopefully visually we can see that these lines are probably not parallel. They look a lot wider, further apart from each other as we go to the left, and as we go to the right, they get closer and closer together. If we were to zoom out on this, these lines would continue getting closer until they intersect each other. But let's go ahead and take a look at their slopes. Again, we're going to find that rise over run. So I'm going to connect these 2 points on our first line. So our rise is -1. Our run is 2, so our slope for our first line is -1 over 2, or -1/2. And then let's do the same thing for the second line. We're going to, again, connect those 2 points. Our rise is -1, so that part matches, but our run is 3. So our slope for this line is -1/3. So because these two slopes are not exactly the same, then these two lines are not parallel to each other. I have a few more examples for us. I do have a companion video that goes over perpendicular lines and how to use a slope to determine if two lines are perpendicular to each other. So I will have that link for you in the description as well. And I also wanted to point out that I am offering math tutoring for students in 2nd grade all the way up through high school. I work with students in algebra, geometry, algebra 2, and statistics. So if you're looking for more math support, then please feel free to reach out to me. You can email me, or I have my links in the description where you can contact me. All right, let's go ahead and see if we can figure out if these lines are parallel. In this first example, we have 2 equations, and both of the equations are in slope-intercept form, so that makes it really easy to identify the slope. If an equation is in standard form, you would want to convert that into slope-intercept form or point-slope form if that is easier for you. Both point slope and slope intercept, you can see the slope by just looking at the equation, and that slope is going to be that coefficient that's with the x. So that means that both of the lines that these 2 equations represent are parallel to each other. Let's take a look at these other 2 equations and the slopes for them. So we've got a 3 and a 4, not the same slope, so right off the bat, we can tell that these 2 lines are not parallel. Now, in my next 2 examples, we are given 2 points on 2 different lines. So these 2 points, -3, 4 and -1, 1, those are 2 points that exist on one line. And then these 2 coordinates are 2 points that exist on a second line. So we need to find the slope. And I do have another video that goes over how to find slope from 2 points. Again, link in the description below. And this is our formula, y2 minus y1 over x2 minus x1. So let's go ahead and figure out what the slope is of these 2 lines. So I like to always label my points with x1, y1 and x2, y2. That just really helps to make sure that I'm placing these numbers in the correct spot in our formula. And let's go ahead and substitute those in and solve. So our y2 is 1 minus 4, that's our y1, over our x2 is -1 minus our x1 is -3. So we could write minus a -3, but I like to simplify it and just go ahead and make it a +3. So let's go ahead and simplify and solve. 1 minus 4 gives us -3. And then -1 plus 3 gives us 2. So we wind up with a slope of -3 over 2. All right, let's see what our slope is for this second line. So again, x1, y1, x2, y2, and let's sub those numbers in. -5 minus a -2, I'm going to go ahead and write that as +2 over -2 minus -4, so -2 plus 4. So we get -5 plus 2 gives us -3, and then -2 plus 4 gives us 2. So our slope for this second line is -3 over 2. So because those two slopes match, we do have parallel lines. Okay, we've got the same setup over here, so let's go ahead and label x1, y1, x2, y2, and figure out the slope for this first line. So 6 minus 2 over 3 minus 1. 6 minus 2 is 4. 3 minus 1 is 2. That reduces to 2. So our slope for this first line is 2. And then for our second line, we've got x1, y1, x2, y2. And so then 3 minus 0 over 2 minus 0. So that's going to give us 3 over 2. We can't really simplify that. We're going to leave it as an improper fraction. That's typically how we deal with improper fractions with slope, is just leave them improper. We don't want to turn them into mixed numbers. Regardless, we can see that these two slopes don't match. So that means that these lines are not parallel. Thanks so much for watching. I hope that this video was helpful for you. As I said before, I do have a companion video that goes over perpendicular lines, so check that out. Also, don't forget to like and subscribe. That really does help me to continue making these videos. And if you would like to, go ahead and leave me a comment. Let me know what you thought of this video, and I'll see you next time.